doing the Pythagorean theorem backwards. By now, you've had a chance to get acquainted with the Pythagorean theorem. You know the formula, a squared plus b squared equals c squared, and more importantly, you should know what it means, namely that if you take the length of the two legs of a right triangle, square them, and add them together, you will get the square of the hypotenuse. That's the long side across from the right angle. Here's everybody's favorite example. If you have a right triangle with one leg 4 units long and the other leg 3 units long, then you know that the hypotenuse has to be 5 units long. You get this because if you square 4, you get 16, and if you square 3, you get 9, and if you add them together, you get 25, which is 5 squared. People have known about the 3, 4, 5 triangle for a long time. So far, most of the problems you've been given with the Pythagorean theorem have looked something like this. You start out with a right triangle. You know it's a right triangle either because the problem explicitly tells you so, or because you see this little box in the corner, or both. You are then given the lengths of 2 of the sides of the triangle and asked to find the third. But the Pythagorean theorem also works the other way. If the sum of the squares of the 2 shorter sides of a triangle add up to the square of the length of the longer side, then the triangle has to be a right triangle. Here's an example of how this principle might work. Take a look at this triangle. It has sides 45, 28, and 53. It looks like a right triangle, but how can we be certain? The best way to test this is to see if it passes this Pythagorean theorem method we've just suggested. We'll take the 2 shorter sides, square them, add them up, and see if we get the square of the longer side. This is definitely a case where you will want to use a calculator. First, we set up our formula, 45 squared plus 28 squared, and see if it equals 53 squared. If this is true, we have a right triangle. 45 squared is 2020. 28 squared is 784. 53 squared is 2,809. If you add those first two together, you'll get the third one. So yes, we have a right triangle. Let's try it on another one. This triangle has sides 20, 5, and 22. Like the last one, it looks like a right triangle, but we can't be sure until we test the sides using the Pythagorean theorem. Once again, we set up the formula, 20 squared plus 5 squared, and see if it's going to be equal to 22 squared. If we try this, we get 400 plus 25 and 484. Well, those don't add up. We end up with 425 and 484. Those aren't equal, so therefore it is not a right triangle. Let's do one more. The sides of this triangle are 20, 21, and 29. We set up our formula. We get 20 squared plus 21 squared equals 29 squared. Let's check the numbers. 400 plus 441 does equal 841, which is the square of 29. So, yes, we have a right triangle.